Hello, 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 ladies and gentlemen, and welcome back. We're continuing our look at the 2007 Cayley contest, and we're on our second last question, question number 24. Hopefully you guys at home have given this a look-see, tried this question out for yourself. Let's dive into it together. The number 8 is the sum and product of the numbers in the collection of four positive integers 1, 1, 2, and 4. Since 1 plus 1 plus 2, so that's a total of 4, plus another 4 is 8. And 1 times 1 times 2 times 4 is 8. The number 2007 can be made up from a collection of n positive integers that multiply to 2007 and add to 2007. What is the smallest value of n with n greater than 1? Oh, okay, because otherwise I could just say the set was 2007 and I'd be done. So I need at least two numbers. And so since they have to add to 2007, they'll both be less than 2007. Interesting. Okay, so they give us an example, and the first thing I see from this example is there's more ones than you might think are necessary to make the product, but they're there because if I just split up 8 into 2 and 4, I come up with 6, so we add in as many ones as we need to get to this 8. So I think the plan of attack is break 2007 down into some factors, 3 of them, 4 of them, 5 of them, and that product will multiply to 2007, and then any number of ones we won't change the product, and we can add in as many ones as we need to make everything add up to 2007. Okay? 1 is the only real number that we can add here. We can always add in as many numbers 1 as we want, and the product won't change, but the sum will increase by 1 each time. Okay. So, let's see here. What can we say? We can always add ones without changing the product. Allowing us to increase the sum to whatever we like. So, I think because the ones don't matter, we'll just add in a bunch of ones no matter what we do. So all we need are some numbers that multiply to 2007, and we just add in as many ones as we want. And we're going to be adding in a lot of ones, I think, because 2007 here does not have that many factors. 9's a factor, so we got 2 3s and then some other numbers, but there's not going to be that many, and so we're going to have to, the bulk of these, 1,171, 1,551, we're going to be adding in a lot of ones to make up the difference. I think our goal now is to minimize the number of ones we need to add. So our goal is to minimize number of ones, because remember what n is, and we're trying to minimize n. N is the number of numbers that we need to make a product and sum both be 2007. So I'm minimizing the number of ones we needed to add. Well, the ones aren't added for the product, the ones are added for the sum. So we want to break 2007 into some set of non-unit, so not the number 1. Non-unit factors that have the greatest sum. So it's probably very important in this question to know what the factors of 2007 are. And actually, this is sort of a comment that can be made, and I do occasionally make it, for any of the Waterloo contests, or really, this happens with a lot of math contests anyway. The number of the year and the next year and the year before it tend to come up a lot, especially whatever year you're looking at. So we're looking at the 2007 Cayley. Expect the number 2007 to come up somewhere in some question. I was actually talking with a colleague about this a week ago when we were doing a math camp together. You should know properties of the year number going into any contest. Like, if the contest is being written in 2003, what are the factors of 2003? Is it prime? Can I write 2003 as a sum of squares? Can it be written as a sum of two squares? How many ways can I do that? Just fun, trivial little facts about 2003, 2007, 2015, whatever you want. Is the number itself a square? Is it a cube? That sort of thing. Is it a power of 2? These are all useful things, but especially its factorization, I feel like that comes up a fair bit. So it's something to have sort of memorized before you go into a math contest, and you have just that slightest bit of an edge. Okay? So 2007, well, I can see it's got a factor of 3 here, because the digits 2 plus 0 plus 0 plus 7 add up to 9, which tells me actually I have a factor of 9, but I'm going to write it with prime factors. And then we'll have 9 into 22, remainder of 2, so 9 into 20 is another 2. I guess those will be written down here. 2, 2, and then 27, so that'll be 3. I guess that makes this 6, 6, 9. 2, 2, 3, is this prime? I don't know off the top of my head, no. It's not even, so it's not a multiple of 2. It's not a multiple of 3, because 2 plus 2 plus 3 is not a multiple of 3. It's good to know your divisibility rules. For exactly this sort of a situation. It doesn't end in a 5 or a 0, so it's not a multiple of 5. Square root of 223, well, this is close to 225, so it's a little less than 15. So if I want to check if this is prime, I just need to check, is it divisible by any prime less than 15? 7 into 223, you're going to get a 3, 21, and that'll be a 13, so no. 11 into 223, that's going to be a no right away, because there's the 2. You'll be left with a 3. 13 is the last one we need to check. I'm pretty sure this is also going to be a no. 13 goes in here once. We're left with a 9. 93, so close. It's 91 is the next multiple of 13. So 223 is in fact a prime. So these are the factors. So 2007 is 3 times 3 times 2023. Okay. So what can we do? Well, these are not that many factors. So what I could do is I could just write out all the possible ways to break 2007 into some non-unit factors. They don't have to be prime factors. Just some non-unit factors. So I could write 2007 is 3 times 669. But what I care about is the sum. 3 plus 669. Or I could write it as 9 times 223. And then you can see right away, without even calculating these sums, the second one is going to be a lot less. What else could we have? We could... Is that it? No, we could have 3 times 3 times 223. But then that is it, isn't it? And then that sum would be 3 plus 223. Okay? And that's going to be 3 less than the one before it. So the best we have here is 3 and 669, which is 672 as the sum. This one down here is 232, and this is 229. And there's really no other way I can break these down into other sums, is there? I have the 2 3's together, but since I have to have 2 factors, that leaves the 223 on its own. I have 1, 3 separated, doesn't matter which 3 because they're identical, and then those 2 combined, and then I have every single thing separated out. Yeah, those are my only possibilities. So 6, 7, 2 is the most I can get without ones. And that's fine. 3 times 6, 6, 9 is good. So what are we going to have? We're going to have a whole bunch of ones, like a lot of ones, a lot. And then we're going to have 3 and 6, 6, 9. And that'll have a product of 2007. Here we have a sum of 6, 7, 2. So how many ones do I need? We'll call it X. And X plus 6, 7, 2 has got to be 2007. So we rearrange. X is 2007 minus 6, 7, 2. Subtract 2 from the 7, you'll get a 5. 200 minus 67. Got a 5 there. Turn these into a 19 and a 10. We'll get a 3 there. So 1, 3, 3, 5. So n is the x1s plus these 2 factors. 1, 3, 3, 5 plus 2. 1, 3, 3, 7, which I think was answer B, and was actually one of the lower ones. Yeah, so there it is. The only thing lower is 1, 1, 7, 1. So let's just think about it for a second. Could we have that? I don't think we could. Really, the only question is, did I miss a factoring up here? And I definitely don't think I did. Because 223 is prime, so I can't break this up anymore or rearrange anything. So, yeah, I think B is definitely our answer. 1337 is the smallest n that we can do this with, other than, of course, the trivial set of 2007 by itself. But that was an interesting question. I like that one. And we got one more question to go on the Cayley. Hopefully it's just as interesting. I will see you guys for that next time. It's question 25.